for the problem number 2. Okay? Something like that. This one. Okay? So, it's gonna be like that. It's equation 1. So, equation 2 mga palangga, okay. You need also to solve for the horizontal axis. Okay, it's gonna be summation of fx net is equal to, here we don't have forces here for the block because it's going downward. Okay, we are now focusing on the tension. So negative T1 because it's in the negative part at left, and then negative T1 cosine. Okay, cosine 60 because horizontal, right? Cosine 60, correct? Yes, correct. And then we have also here positive T2 cosine of 30. Okay, ganon. Okay, so 0 also your fx, because you don't have acceleration, you don't have speed, like that, you have this, no distance, you don't have time. Okay, so that's going to be the philosophy behind that. Okay, cosine 60 is equals to 0.5. Okay, so negative T1 0.5 and then plus T2 cosine of 30 degrees. Okay, cosine of 30 degrees is equals to 0.866. 0.866. Okay. Take note, this is our equation 2. And then simplify that further, and then it's going to be like transposed. So negative 0.5 T1 plus 0.866 T2 is equals to 0, right? Equation 2. Right? It's your equation 2. Mga palangga. Now, equation 1 and equation 2 have the same variables. T1 and T2. You can solve T1, you can solve T2. Okay? Anywhere you want. Okay? Whatever you want, something like that. But be careful also with the sign. Okay? So let's take here equation 1 here. Actually, you can also use equation 2. It depends on you. Huh? Okay, ganon. So, but take note, the equation 1 have 3 expressions and the equation 2 have 2 expressions. I must go to the more simplified. I will go here. Okay, so let's say I will try to solve for T2. So T2 is T2.866 T2 is equals to transpose 0.5 T1. So therefore I could say that T2 is equals to 0.5 T1 over 0.866. Okay. 0.5 divided by 0.866 pila siya. So 0.5 divided by 0.866 is equals to 0.57736. 0.57736 T1. So this is your equation 2. Okay? Like that. So I must erase the drawing because it's consumed a lot of space in my magnetic whiteboard. I must say like this. We write the equation 2. So equation 2 from equation 2. We have T2 is equal to 0.57736 T1. Okay. Now we have the equation 1 here that involves also the variable T2. Then you can substitute this T2 here to equation 1. Okay? So that you can solve for the values of T2 and then later on T1. Okay. It's going to be 0.8, this is from equation 1. From equation 1, it's here, 0.866 T1, okay, and then plus 0.5, the value of T2 is this one, okay, see, T2 is equals to 0.57736 T1, right, and then minus, okay, minus 588.6 is equals to 0. Then solve for T1. Okay, you can easily use same variable already, T1. Okay, so 0.57736 times 0.5 is equals to 0.28868. Okay, it's gonna be 0.866 T1 plus 0.28288, right? Yeah, 68 T1 is equal to, transpose this to the right, will become positive 28.6, then 0.866 T1 plus 0.828868 T1, how much? Okay, plus 0.866 is equals to, we have 1.15468, so 1.15468 T1, then therefore 588.6 divided by this one, 1.15468. T1 will be equal to tension 1 in your first row at 60, at 60 degrees, right? So it's gonna be like 58.6 divided by 1.15468 is equal to 509. Review. So 588.6 divided by 1.15468 is equals to 509.75 Newton. Your tension 1. 509.75 Newton. Now you can solve also the tension 2 by substituting back at your equation 2. So this is going to be 0.57736 times T1 here. So pila siya. Okay? So times 0.57736, right? Okay. We have 294. Okay? Really? Yes. Our T2 is 294.31 Newton. Okay. So I will erase this one, because to save the space, like this. Okay. So we are now having the T2 and T1. Let's rewrite that in a clear space. Okay, so we need to still solve the components forces, tension forces. Okay, so, oh my gosh. So we have T2, 294.31 Newton. T1 is 509.75 Newton. Meaning to say, the tension 1 has a greater tension force than the tension 2 of the second row. Okay? Why? Because the other one has a higher angle of inclination, which is 60 degrees. Okay? Like that. Dito po yung mga palangga. Okay, it's gonna be like that. Now, solve for T1x, T1y, T2x, T2y. These are the tension component forces. Okay. T1x, it's gonna be T1. You have now. So T1, okay, cosine, okay, 60 degrees. So T1, 509.75, okay, cosine, 60 degrees. Pila ang imong T1x. Okay, mga palangga. So it's understood to be your T1x is equal to T2x. Diba? Let's check. Okay. So we don't know yet, but let's try to solve this. Okay, cosine 60 is equals to times 509.75 is equals to 254.875. Your T1x, 254.875 Newton. How about your T1y? Your T1y will be equal to T1 sine of 60 degrees, then T1 is 509.75, then sine of 60 degrees. Okay, how much is that? Your T1y, vertical component tension force. Okay, cos sine, sine 60 is equals to times 509.75 is equals to 441.46 Newton. Okay, 441.46 Newtons. So it's gonna be your vertical tension force of your rope 1. Okay. Now you go to your rope 2. Okay. T2 horizontal cosine of 60 degrees. And now we have T2 here already resolved. 294.31 and then cosine of 60 degrees. Now your tension force of the rope 2 in our horizontal axis will be, okay, cosine 60 is equals to times 294.31. So it's gonna be 147.155. So 147.55 Newton. Ganon. Okay, your T2y will be T2 cosine, okay, like that. See, for example, Tx cosine sine 60. So this is also sine, okay, sine 30. Okay, because this is 30 degrees in the second angle. Okay, be careful also. Bilamihan ang ka-solve. Sige, nakagamit ng 60. Di ba, mga kaloka? Okay, cosine 30. Yan, guys. Okay, times 294.3 is equals to, we have 254.871. Okay, 284.571. Ang clue na bunyanin yung ganyan ng mga kalawta, imitar. Okay, wait, I'll explain. 254.875 Newton. Then T2 is equal to 294.31 sine of 30 degrees. In case of the situation that there are a lot of angles, you should be careful writing the angle. Okay? If you miss the problem, it will wrong. It will become wrong automatically. Okay? So times 294.31 is equals to 147.55. Okay, your T2y. 147.155 Newton. And now, let's do the analysis. Okay, so if we have here the setting, and the 60 degrees rope, 30 degrees rope, and we have the black here, which is 60 kilogram. So it's understood that your T2, okay, T1x negative is equals to your T2x. So that you have a horizontal net force of 0. So check here. T1x, where is that? 254.875. Where is your T2x? It's here. Equal 254.75 to 254.75. But the only sign is the other one is negative. So meaning 0 and net force is perfect. Your T1x and T2x are correct. Okay. Now, how about your vertical components? So T1x. Your T1x is here, right? Okay, T1x. Okay. Not T1x, T1y, because we are already in the y. So T1y, like that, and then T2y. Okay? Now, napalangga kong hitan. Kung saan man yung pagkuhan, ang higayon na. Okay, so, you have, okay, force net vertical is equals to, bubalik sa itong equation before, okay, but mga nakalagay sa T1, okay, sine of 60 degrees plus T2 sine of 30 degrees, okay, and then you have Fy na siya. Because sa teacher mo makakapag-summation of Fy, okay, kila siya. I-add mo ang tanan. Okay, vertical na siya. So 30 sine 30 mga palangga times 294.31 is equals to 147.55 here. T2 147.455, and this is positive, right? Because it's going upward. And the other one also is positive, it is going also upward, right? All are positive. Okay, then times T1, which is 509.75, is equals to 441. Okay, 441.456. So your horizontal forces in terms of tension 1 and tension 2 plus 147.155 is equal to 588.611. Okay, your total net force vertical between the rope 1 and 2 is equal to 588 0.61 Newton. So, this must be equal also to your weight. Okay? To your weight. Because the weight is going downward, and then your vertical force is upward. To be in equilibrium, they must be equal. Let's check if it is really equal. If not equal, your answer is wrong. Okay? So weight negative, so negative. Then mass is 60, and then your acceleration due to gravity is 9.81. So it's expected also this is 58.61. Let's check. Okay? Kaubo kita lang pareho guys. Okay? Perfect. Okay? 588.6 is equal in your analysis. Okay, this is negative 5.6 Newton because the weight is going downward. Okay, so things like this, you need to confirm if it is stable, it's following the second law of Isaac Newton. So in this case, mga palalaking, if there's no, the technique here, if there's no given distance, there's no given time, there's no given velocity, there's no given speed. Four are not given. Only the forces are involved, or only forces are acting in the object. Then you need to equal the vertical forces to 0, and the other ones for vertical forces 0. Why? Because nobody pushing them to move. Because there's no velocity, there's no acceleration. If there is acceleration, velocity, and time, whatever, then you don't use this equal to 0. Your assumption will not be the same way. Okay, like so that's why this kind of problem proves the second law of Isaac Newton. Saan to siya? Okay, the body object at rest will remain at rest unless acted by a net force. Is the first law. The second law, okay, an object in motion will remain in motion unless acted by a net force. Okay, ganon. So mean to say, if net is 0, meaning the object is remaining in motion. Okay, but the motion is not really going very far to the stationary the object here, stationary location. Like this, like a vibration on it. Ganon. Mura siya nagbangga-bangga na siya kamay. Ganon. Okay? So, imo siyang timanan. Okay? Get the point? So, imo sa timanan sa kanang sa theory, ang imo timanan sa law of inertia, sa first law, ang iyang kuan, ang iyang rest, the word rest. And the second one, the word motion. Okay? Nipunan lang yun yung mga object. An object at rest will remain at rest unless acted by a net force. So, imo siyang punan para mahimong sentence. And then sa second law, okay, an object in motion will remain in motion unless acted by a net force. So, nasa siya word na remain. Ang remain na sa duha ka law. Okay? Dito point, ang differential lang sa inertia rest, ang sa acceleration motion. You get the point? But na-remain, nasa siya net force. Then bingo, you can memorize completely the definition in terms of statement. This is converted to formula and equations. What I'm trying to emphasize is in terms of statement. Okay? Letters, words, like that sentence. Okay? You get the point? It's gonna be like that for this. Any questions so far? Okay, nothing, right? So, time will come also, guys, na mag-rumble niya siya. There will be a applied force here in the left, frictional force on the right, normal force on the opposite. So, these are the most complicated because the forces are acting on it. Okay? But in this case, you don't have to worry because there's no kinematic linear motion. Okay? That point mo pala pumunta. Okay? But our first example have acceleration, right? That's why we don't put 0. Right? In our first example. Okay? Like that. Get the point? So, there's an acceleration rule, guys. So, I mean to say, dili siya duha ka rope ang i-attach. Because normally, if 2 ropes will be attached, it will be balanced. Okay? But if it's only 1 rope, there's a tendency that it will accelerate. Common sense. Okay? Accelerate up, accelerate down, or even a little bit acceleration going to the right, to the left, something like that. Because only 1 rope is being attached or connected. Okay? Something like this. So there's instability or unstable na siya compared to this examples. Any question? Okay. This last question, this is taken in the Chemical Engineers Board Examination in 1982. Okay? Di ba, gusto kayo 1982 guys noon, yung angle-angle. Okay, maybe in 1982, show your solution pa. I think so. Show your solution. It was lately changed into computerized. I don't know. But in the past, the board examination, all engineering board examination are show your solution. That's why siguro in ano siya type of problems. Okay? You get the point? Because if it is a multiple choice, you don't have to go very, very far. You get the point? Nakakaloka. So, if you like this video, you can comment down below in the comment section. And then you can also subscribe to my channel. And then you can click the bell notification for some news updates about the singer, Eternal Bonus. Thank you for watching, Ma'am Raquel. Obesu, bye-bye soon, classmate in my elementary education, Sapok Central Elementary School. Okay? Bye-bye. See you later. Okay.